What's up, guys? So let's talk about the long division of polynomials. And what I mean by this is if we take a polynomial, so this x cubed plus 5x squared minus 32x minus 7, and divide it by another polynomial, this x minus 4, what is the result going to be and how do we go about that process? Now, before we get into dividing polynomials, let's do a little review of long division with integers, because the process of doing long division with integers and polynomials is pretty much the same. It's very similar. So 841 divided by 25, we can rewrite the division like this. And then what's the next step? So we see how many times can 25 go into 8? Well, it can't go into 8 any whole times, so then we check how many times can it go into 84. Well, it can go into 84 3 whole times. And then 3 times 25 is 75. So we put the 75 here. And then we take 84 minus 75, and that gives us 9. And then we bring the 1 down, so that's 91. And then we check how many times can 25 go into 91. Well, it can go into 91 3 whole times. And then 3 times 25 is 75. And then 91 minus 75 is 16. And then we check how many times can 25 go into 16. Well, it can't go into 16, so 16 ends up being our remainder. Now, I want to go over what each of these pieces is called in the division because it's very important for this section, so make sure you write this down. So this 16 over here, as we mentioned, this is the remainder. This 841, or the part that we're dividing, is always called the dividend. The part that we're dividing by is called the divisor. And this 33 here, the result that we get is called the quotient. So if we rewrite this result in a statement, basically 841 is equal to 25, the divisor, times the quotient, 33, plus the remainder of 16. So if you did this in your calculator, you would get 841. So if we put this as a general statement, basically the dividend is equal to the divisor times the quotient plus the remainder. Dividend is equal to divisor times quotient plus remainder. That always holds in every case. And this here, this general result, is called the division statement, which you will have to know for this section. So now let's go into doing the long division on the polynomial that we have. So I rewrote this, this division right here. And the first thing that you want to always check before you go into dividing polynomials is that they are rearranged from highest degree to lowest degree. And in this case, we were already given the polynomials rearranged from highest degree to lowest degree, but sometimes you might get like this 5x squared in front, or maybe this negative 32x in front, or maybe this divisor would be rewritten as negative 4 plus x. So you got to make sure you rearrange it before doing the long division from highest degree to lowest degree. Now, the next thing you want to do when you're dividing is you want to see how many times does this first part of the divisor go into the first part of the dividend. So how many times does x go into x cubed? Well, it goes in x squared times. And if you want, you could do that on the side. You could just basically take x cubed and divide it by x, and you would get x squared. So x goes into x cubed x squared times, and then as we did here when we took the 3 and multiplied by the 25, we take the x squared and multiply it by the x minus 4 and rewrite it here. So x squared times x is x cubed, and then x squared times negative 4 is negative 4 9x squared. And now what we do is we take the dividend and we subtract this whole new expression that we have at the bottom of it. So x cubed minus x cubed is just 0. These would cancel out. 5x squared minus 4x squared, that's the same as 5x squared plus 4x squared, so that would give us 9x squared. And then we can bring down the negative 32x and bring down the negative 7. Now another note I want to make is that a lot of students make a lot of mistakes doing this vertical subtraction. A lot of times they don't take this negative and distribute it to the second part of this expression. So my suggestion is that you do this subtraction on the side before you get fully comfortable doing it vertically, so you're minimizing errors. So basically you can just take this dividend right here and then subtract this whole expression. And then it just becomes distribution property and collecting like terms, etc., etc. So we can rewrite this, x cubed plus 5x squared minus 32x minus 7. Distribute this negative 1 in, so that would be negative x cubed. And then negative becomes positive 4x squared. And then this x cubed and this negative x cubed, they cancel out. This 5x squared, this 4x squared, those are like terms, so that becomes 9x squared. And then minus 32x minus 7 we rewrite as is. And that's what we got here. So doing it on the side might help you initially to get used to the process. So once you get to this point here, you repeat the process. So now you check how many times does x go into this new expression, this new part of the expression. So x goes into 9x squared 9x times, right? Because if we do that on the side, 9x squared divided by x, we get 9x. So the 9x we put here, and then we take the 9x and multiply it by the x minus 4. So 9x times x is 9x squared. And then 9x times negative 4 is negative 36x. And then we minus this whole expression here. So 9x squared minus 9x squared is 0x squared, so we don't have to put anything. And then negative 32x, negative 36x, that's the same as negative 32x plus 36x, so that ends up being 4x minus 7. We bring the 7 down. Again, my suggestion is before doing this vertical subtraction, perhaps do it on the side. So I took this 9x squared minus 32x minus 7, and I subtracted this whole expression here. So distributing the negative inside the bracket, we would get minus 9x squared plus 36x. The 9x squares, they cancel out, and then negative 32x plus 36x, those are like terms, we end up with 4x, and then the negative 7 is just left. So that's how we got this 4x minus 7. Then we check how many times does x go into 4x. Well, x goes into 4x just 4 times, right? Because 4x divided by x is just 4. So we write the 4 here. 4 times x minus 4, that ends up being 4x minus 16, right? Because 4 times negative 4 is negative 16. When we subtract these, we get 4x minus 4x, that's just 0, and then negative 7 minus minus 16, that ends up being positive 9. So this part right here, if I rewrite it, so 4x minus 7 minus 4x minus 16, distribute the negative inside. 4x cancel out, negative 7 plus 16 is positive 9. And then we check how many times can x minus 4 go into 9. Well, it can't go into 9. So 9 here ends up being our remainder. Alright, so let's do a recap of what each part is here. So this here was our quotient. This part here was our divisor. And this part here was our dividend. So I took this result here and I rewrote it as the division statement because your textbook and a lot of teachers require you to do so after you do long division. So basically the dividend of this x cubed plus 5x squared minus 32x minus 7 is equal to the divisor, this x minus 4, times the quotient of x squared plus 9x plus 4 plus the remainder of 9. Now, a couple of extra things that I want to make a note on before finishing this video. First off, notice how always these first couple of terms, this x cubed, this 9x squared, this 4x, they're always canceling out, right? You always end up with a 0x cubed or a 0x squared or a 0x. So make sure when you're doing this process, those first terms are canceling out, because if they're not canceling out, then you're probably doing something wrong. Two more ending notes that I want to make. I wrote these ending notes here because I sort of ran out of room, so you could write them wherever on your page. But the first one is the degree of the quotient, which is the highest exponent in the polynomial, the 2, is always equal to the degree of the dividend, which is 3 in this case, minus the degree of the divisor, which is just 1. But this relationship always holds. The degree of the quotient is always equal to the degree of the dividend minus the degree of the divisor. The second point that always holds is that the degree of the remainder is always less than the degree of the divisor, meaning the divisor can't go in the remainder. Now, in the next few videos, I go over more examples of long division of polynomials. It covers certain scenarios and certain tricks that we didn't go over in this example, so make sure you go and watch that.